Okay, so in this example here, instead of having a cosine squared, I have a cosine cubed involved in this problem here. And so the idea here with these integral involving powers of cosines, powers of sines, or powers of both, is we want to rely on a couple ideas. First, of course, is this underlying relationship between sine and cosine. Right? Cosine squared plus sine squared equals 1. That allows us to make that transition from either a cosine to a sine. The other thing we want to rely on is that the derivative of cosine involves sine, and the derivative of sine involves cosine. So what we'd like to have when we're dealing with a thing, so that if I try to do this right now, the substitution let u be cosine, then du calls for a minus sine x that just isn't there. Right? It's just not there, and I can't just make this become u to the third, which would be really nice. Now, if there was a sine x in there, then I could just let u be cosine cubed, or cosine x, and then I could carry the substitution through. Okay, so that's the idea. So I'm going to do something here, and it might not quite make a lot of sense at first, but once you start seeing these worked out, it'll start, I hope, to make a little more sense. So I'm going to take that cosine cubed and rewrite that first as cosine squared x times cosine x dx. Now I have this cosine dx stuff with it. Cosine is the derivative of sine. So if I had a sine in there that I needed to deal with, or if instead of being cosine squared there, that was a sine squared, well, then I could let u be sine, and I would have its derivative ready to carry through. So we can make that become sine by invoking the identity. Right? Cosine squared plus sine squared equals 1. So therefore cosine squared is 1 minus sine squared. And then we still have that cosine x dx hanging around. And of course this needs to distribute. This needs to distribute. So that would be integral of cosine x minus, I'm going to do that as dx. Just break that up as 1. And then minus the integral of sine squared x. And then I still have that cosine x dx, which I'm going to group together in a moment, and you'll see why. I'm just going to go ahead and group it together. Because now this stuff, cosine x dx, is the derivative of the inside function here, the sine. So this is actually tailor-made now to set up for the integration by parts. Okay. Or not integration by parts, for the basic substitution. Alright, so I just let u be the inside function, sine, and then du be the derivative of sine, cosine x dx. Alright, we have everything we need. So that's going to make this, just working out this piece of the integral, minus the integral of u squared du. Well, since it's u squared now, we just use our power rule. Add 1 to the exponent, divide by it. Minus 1/3 u cubed plus a constant. And then we substitute back in for sine. So the overall thing now we can actually work out. First one, integral of cosine, is just sine. And then minus 1/3 sine cubed of x plus a constant. So now we know the integral of cosine cubed. We now know the integral of cosine cubed of x. It's sine x minus 1/3 sine cubed of x. And so it hinged on this idea that I had this extra piece laying around. I could make an extra piece laying around. And then I was left with the cosine squared laying around, which I could transform into sine, and then work the problem out.